An estimated 2 billion people worldwide live in areas that lack proper solid waste management systems. Inadequate waste systems present serious risks to human health and the environment. The United States Environmental Protection Agency's Best Practices Guide for Solid Waste Management and accompanying learning modules present best practices for solid waste management in developing countries. This video builds on the waste characterization section of the Best Practices Guide to provide more detail on how to assess a waste stream and how this information informs waste management solutions. Waste management approaches differ based on the types and quantities of materials in a waste stream. Because waste composition varies city by city, waste characterizations are an important first step to design and implement effective waste reduction and management strategies. As the saying goes, you can't manage what you don't measure. For example, if a city finds a high quantity of recyclable materials in their waste stream, they may consider a new recycling program or develop a behavior change outreach plan to increase recovery. Cities should perform waste characterizations to understand the source or where waste is generated, quantity or how much waste is generated, and composition or the various types of products and materials in the waste stream. Characterizing waste by source helps decision makers tailor solutions to the target audience, from households to businesses in their community. Common source categories include residential, including single-family homes, apartments, or other informal and formal housing. Commercial, including office buildings, shopping malls, airports, restaurants, and markets. Institutional, including schools, medical facilities, and prisons. And industrial, including manufacturing or processing facilities. Understanding the quantity of waste helps decision makers develop and size solutions according to how much waste is generated. Cities can use waste quantity data to develop waste generation baseline measurements, set reductions targets, and to estimate greenhouse gas emissions from the waste sector. Cities can either model or measure waste quantities. Cities can model the quantity of waste generated by using generic waste generation rates from neighboring cities with similar demographics and sources. Modeling the waste quantity is less expensive, but only provides a general idea of waste volumes and types. Measurement techniques are more accurate than modeling, but are also more expensive and time-consuming. Measurement techniques include conducting waste audits by sampling, measuring and recording the waste quantity and composition at the point of generation, transfer station, or disposal site. Reviewing records from waste generators, including commercial, institutional, and industrial generators to estimate the generation quantity. Cities can also review records from disposal facilities to estimate the amount of waste disposal at a facility. Surveys of waste collection vehicles provide estimates of waste generated by different sources and how they are being managed. Waste composition refers to the variety of materials and products in the waste stream, including organic materials, plastics, metals, e-wastes, paper products, and more. When studying waste composition, cities can add or remove subcategories as needed to best capture their waste stream. The World Bank estimated the waste composition of low and middle income countries around the world. Low and middle income countries generally have higher fractions of organic wastes. The fraction of paper, plastics, packaging, and electronic waste generally increases as economic status advances. Understanding the current and projected waste composition helps cities develop solutions by waste types and quantities. For example, cities can use data on the quantity and composition of organics in a waste stream to implement organic waste separation policies and design appropriate collection and treatment programs. Conducting a waste characterization study is an important first step in designing and implementing effective waste reduction and management strategies. To conduct a waste audit, first determine the location of your waste sort. Studies can be at waste generation sites such as cafeterias, markets or office buildings, transfer stations, and final disposal sites. Avoid conducting a waste sort after major events or holidays, as this may not capture an accurate picture of the waste stream. At the waste audit location, work with waste haulers to set aside routinely collected waste to be studied. To set up, obtain containers for sorting the waste. Select the size of the container based on how much waste you intend to sort. For example, baskets may work for small loads, while large garbage cans may be needed for bigger loads. Weigh each container, ensuring you have a record of each weight. Set up bins with general categories such as paper, plastic, glass, metal, organic waste, e-waste, and hazardous waste. Remember, you can create as many categories as are relevant to the waste stream. After setting up the site, sort the waste by predetermined categories and place into your labeled containers. Weigh each filled waste container and subtract the weight of the container to obtain the net component weight. With the data from the sort, you can use the total tonnage data from their entire waste stream to extrapolate how much of their waste stream falls into each category. Waste characterizations develop a waste profile which decision makers use to plan future solid waste management activities. That is exactly what the city of Naucalpan, Mexico did in 2017. Naucalpan, a suburb of Mexico City, faced several solid waste management challenges, including large quantities of waste and an ineffective system for handling organic waste. In partnership with the U.S. Environmental Protection Agency on behalf of the Climate and Clean Air Coalition Waste Initiative, Naucalpan conducted a waste characterization study at one of their transfer sites. The study indicated that approximately 69% of the waste handled at the transfer station could be recycled or otherwise diverted from the landfill. More than half of the waste analyzed as part of the study was organic and could be used as feedstock in composting or anaerobic digestion projects. The city is planning to use this study's results to inform future waste management decision-making. The city of Phoenix, Arizona, in the United States, used the following approach. At predetermined locations, city workers and researchers superimposed a grid over the dumped waste. The site leader randomly selected cells from the grid from which to extract waste. The contents of each selected cell were removed from the dumped waste and placed on tarps. The content of each cell was photographed, sorted by hand, and weighed. The city then used the total weight of their entire waste stream to extrapolate the composition based on the waste sort. This approach does not use technology-intensive process and can be replicated in developing countries around the world. Waste characterizations differ in every city around the world. The different types of solid waste require different solid waste management strategies. Therefore, cities must understand their waste streams in order to design and implement appropriate systems, including identifying valuable recyclable materials and developing end markets for recyclables. Visit Section 7 of EPA's Best Practices Guide for more information. The guide is part of EPA's Solid Waste Management Toolkit. Scan this QR code for more information. Thanks for watching.